Hi, in this video, I'd like to introduce you to the idea of type conversion in Python. Now, conversion is in quotes because even though we appear to be converting between types, that's not technically what we're doing. And I'll explain that in a bit. Now, before we actually talk about type conversion, there's one thing that we want to make sure that we are on the same page. And that is print 4 raised to the second power, or 4 square, in quotes, versus print 4 square without the quotes. So, think for a moment that what do you expect each of these statements to print? Okay, so let's actually run that. I've already typed it out here. And when we do that, this is what we will see. The first one is that we print out 4 asterisk asterisk 2 exactly as they appear in the quotes. The second is actually it prints out 16, which is 4 square, right? And I hope you understand why they behave differently, right? Because the first one is anything in quotes are, you know, a string literal, so they're going to be printed out as it is. The second one, because they're not in quotes, this is an arithmetic expression that Python will evaluate, and it is evaluated to 16, and that's what Python prints out. And that's what this slide explains. Okay, so with that, let's do something a little more realistic and maybe a little more useful, slightly more complicated as well. So far what we've done is we either just print out a number or just a string all by itself. We haven't mixed them together yet. Now, what if we actually want to print something like 9 raised to the 123rd power, and we actually want to put that result on the same line. Now, that is going to result in a very big number, 9 raised to the 123rd power. So how can we do that? Well, one way we could is that we could use Python to compute the result of that, and we copy and paste the result in the string and call it a day. So that's what I mean. So we print out the result here, we calculate it, right? And let's run that. That's going to result in a ginormous number. You can copy that number and then put it here, right? Whatever it is, we don't care. We just copy and paste it. And then we can run it again. And yeah, we're going to have this expression or this statement telling us the result of doing this calculation. Now, that works, but there are problems with this approach, right? So first, that's a lot of work to copy and paste the number. And the second problem is if we change either the base or the exponent, then we have to kind of redo everything. And so there is a better way. So let's give it a try. First, we know that we can concatenate things together, right? So can we just take this expression and then concatenate it to this string here? I'm going to put parentheses around it to make sure that it does this calculation first. So the hope is, well, it does this, it evaluates 9 raised to the 123rd power, and whatever the result will concatenate it with the expression, with the string literal, and we'll get what we get here. So let's try to see if it works. Okay, it doesn't. It actually gives us something red and some sort of type error. Now, it is important to learn to read this kind of error. This is called stack trace. Okay, the first thing that we want to see in this stack trace or trace back is where does the error actually occur. And it would tell us the line number is line 22, so you can see the line number in your editor, or you can simply just click here and it will bring you to exactly the line where the error occurs. So it is this line. Now the next thing, well, it actually even showed that line in the traceback itself. The second thing we want to pay close attention to is the actual error itself. Here it says it's a type error. And the description here says that can only concatenate string to a string, not an int to a string. So what does that mean? Well, think about it. Here, this is a string literal. Oh, and by the way, yeah, str means string here in Python. Okay, so this is a string literal. Okay, so that's fine. Now, what is this expression evaluates to? Well, 9 raised to the 123rd power is going to give us an integer, right? So that would be the int that it's talking about here. So what we're trying to do is that we are trying to concatenate, which is the plus sign, a string, anything in quotes, to an int. And that is what Python is not happy about. And that's what these few slides are trying to explain. Okay, so how can we fix this? Well, alright, so if it cannot concatenate a string with an integer, and it actually tells us a hint here, it can only concatenate a string to another string, which means that this integer must be converted to a string. And to convert something to a string in Python, what we can do is we can say str and then in parentheses whatever we want to convert to a string. So that is something we can do. Now, technically, this isn't actually doing a conversion. It is actually constructing a new string from whatever's in the parentheses, in this case, an integer. We don't have to get too hung up with the difference between conversion and constructing a new string right now. Okay, does this work? Well, let's find out. I'm going to run this, and indeed it did work. So that's good. And I believe that's what this slide is trying to explain. Now, I want to take this opportunity to also explain another way of doing the same thing. So let me copy this. Now, instead of doing a string concatenation, I can actually pass multiple things to print. So in this case, well, I'm going to leave the parentheses in. I can pass two things to print. So the first thing is I can give it a string literal, just like before, and separate it by comma, a second thing, and that would be the arithmetic expressions that we want to evaluate. And this actually should also work. Let me run that. Yep, it will give you pretty much exactly the same thing, but you notice there are a couple differences. First is this second thing that I pass to print, the arithmetic expression, I actually do not have to explicitly convert it to a string for it to be printed out. Just remember, we can just print out a number as it is, right? So in that case, print actually would automatically does the conversion for us. So we don't have to explicitly convert it to a string. If the arithmetic expression is passed to it as a separate thing or a separate argument to print. And then also, if you might notice that there is an extra space here. And the reason for that is that print by default automatically insert a single space between each of the things that it prints out. So there is an extra, because there is a space here, and it automatically insert another space. So that's why we have two spaces here. If you don't want to see that extra space, then we can eliminate the space here, and that would give us these two strings that look exactly the same. Now, which way you choose, it kind of depends on your preference and what you want to do at a time. I would prefer this way because, as I said before, print isn't the only way to do output in Python. So if we do the string concatenation, then we can pass the string to potentially other ways of outputting things on the screen. But if print is what you need to do, then this could be something that is a little more readable because it eliminates the use of a type conversion here. Anyway, so that's a little digression, but hopefully it's a useful digression. And moving on. So I'd like you to do a bit of exercise now that using this as a starting point. How about you try computing 99 raised to the 999th power and see what you have to do. So pause the video and give this a try. Alright, so assuming you have done that, so this is probably one approach that you might have taken, that you change the 9 here to 99 and 123 to 999, and again you would change the 9 here to 99 and 123 here to 999. Now, so that works, but we actually have to change 4 numbers here, even though we only change 2 numbers, right? The base and the exponent. So there is a better way to do this. And if you want to pause and think about it, please do so. If you need a hint, I would suggest that you think about using variables. So here would be a better approach to do this, is that we define the base as a variable, and we'll define a exponent as another variable, and then we will actually use those variables here. So we'll say base, and then we have to put the raised to the power in quotes, and then we'll do another the variable exponent here, right? Replace that with the exponent, okay, and then we will do what? Okay, equals. So yeah, it takes a bit of seeing here. I'm going to keep everything on the same screen, so I'm actually going to put this on a new line, and then equals the, now here the expression I'm evaluating is not going to be hard-coded 9 raised to 123, right? Instead, it's going to be base raised to exponent. So assuming I've typed everything correctly here, let me run this, and it would achieve the same output as before. Now, you can question, why is this better, right? Particularly, it seems like, you know, we have to type a lot more here. And looking at this thing, it's actually less readable than what we had before. Now, the advantage of doing it this way is now, if we want to compute 99 raised to the 999th power, then all we have to do is change the value associated with the base variable and the value associated with the exponent variable, and we can run it, and we don't have to change anything in the print, and we get the desired output. So again, this is better because all we have to do is to change the values assigned to the two variables. And as far as the readability of the code is concerned, well, there is actually a better way of building up strings that is more readable, but we'll cover that later. All right, so with that out of the way, I think it's time for you to do another exercise. So remember what we did previously, the example of having a width and a length of a rectangle and calculate the perimeter of a rectangle. So instead of just printing the perimeter as a number, I'd like you to try to print out an entire sentence that says the perimeter of a rectangle whose width is 3 and length is 5 is 16. And obviously, once you are able to do this, change the value of the variables width and length and make sure now this message is still correct. So please pause the video and give that a try. So assuming you have done it, here is how I will write the code. There shouldn't be too many surprises here. One thing I want to point out is if the line is getting too long, if it exceeds 120 characters, or if you want to conform to PAP 8, if it exceeds 79 characters, then you need to break that one long line into multiple lines. And when you do that, remember for binary operators like the concatenation operator, plus, we would put the plus sign in front of the new line. So that's why I put the two plus signs here. Well, so far we've converted number into a string type. Well, we can also convert between just numbers, and specifically between the two types of numbers, integer and floating point numbers, by using int or float. So what int does is that it converts whatever's in the parentheses, in this case a floating point number, into an integer. Okay, so we can print that out right now. Let's just do that. So we get a 1. Now the original number is 1.11. So there's no way we can have an integer that represents completely what 1.11 is. So what int then has to do is just truncate the number or removes everything that is after the decimal point. So in this type of conversion, we actually lose information. So if we do that, you better be sure that you're okay with losing the information. Now, going the other way is this. So to convert, so float, what float does is that it converts or construct a new floating point number from whatever argument it is given. So in this case, it's trying to convert an integer 1 into a floating point number. So if we print that out, and let's run that, we get 1.0. So a floating point representation of the integer 1 is 1.0, which is what we expect. And going this way, going from an integer to a floating point number, we are not losing any information, right? The integer 1 is exactly the floating point number 1.0. And that's what this slide is explaining here. And one thing I want to point out is converting an integer into a floating point number, most of the time in Python is actually unnecessary because Python is smart enough to do that automatically when it needs to. So yeah, you probably won't see this a whole lot. Python variables, they actually do not have explicit type information, unlike languages such as C++ or Java, if you know them. And instead, what happens is that the Python interpreter actually figures out the type of a variable when it executes our code. So what that means is that a variable can be assigned different types of values like what we do here. So we can assign x to 1 first, and then at some point later, we can assign say a floating point number to the same variable x. And then in yet another time, we can assign a string, let's say, to the same variable that used to hold a number before. So this to a C++ or Java programmer would be heresy, something that they would never do. And the language itself doesn't allow it anyway. But in Python, this is possible. Now, while it is possible, usually there is really no good use case to change the type of a variable in the course of execution. So most of the time, I would say don't do it unless you really have a very good reason. And I want to take this opportunity to introduce you to a very useful built-in function that Python has that can tell us the type of practically anything. So the name of the function is just type. I'm going to show you how to use it. So we can just say type, and we give it the object, the thing that we want to figure out the type for. Then in this case, it will be the variable x, and we can print out the type that the type function returns. And I'm going to do that for every single x here. And let's run this. So you can see it prints out 3 results. The first one is an int, as what x was. And the second one, when we change it to floating point, it prints out float. And the last one is when we change it to a string, it is a str, or a string. Now, do notice there's the class. There's the word class here. So class has something to do with the object-oriented nature of the Python language. Let's not worry about that right now. And as a little exercise for the type function, remember float division returns integer and true division returns floating point. Well, now that you know how to use a type function, please use it to verify those 2 claims. Alright, so assuming you've done it now, and I can show you this is how I would approach it. Remember, type can give us the type of pretty much anything, not necessarily just a variable. So here I actually put an expression right in as an argument to the type function. So what would happen is that Python will evaluate the expression first, and it gets a result, and it passes that result as an argument to type. So the result should be a floating point number here for the first expression, and the second expression should be an int. So if we run it, yep, that's what we have, float in int.